Hi, welcome to the Unit 1 Combinations Notes 1.2 Fundamental Counting Principle. I like to call this the fun section, so bear with me. We're going to be going over our notes, so please get out a piece of paper, get a pencil, calculator, whatever you need to be going through this with me. Fundamental Counting Principle says, if event M occurs in M ways and event N occurs in N ways, then the event M followed by event N can occur in M times N ways. What does this mean? It's a whole lot of math. Well, not math, but words that lead into some math, which is the fun part. So let's look at an example. Here's how it works. I have 2 pairs of pants and I have 3 shirts. So what I could do is I could label, let's say I'm going to label these as A and B, 1, 2, and 3. In the last section, we had talked about using a tree diagram. So if I had picked pair A pants, I can choose top 1, 2, or 3. If I picked B, I could also choose 1, 2, and 3. So I have 3 ways and 3 ways, which if I add those together, I get 6. Or, this is my event M from the previous example, and there's M equals 2. This is event N, so N equals 3. And then it said M times N is how many ways? So 3 times 2 equals 6. Kind of nice. A little bit easier on some occasions than doing a tree diagram. This is what we're going over in this unit, or this section. So how many 2-digit numbers are there in our base 10 system of counting numbers? So a counting number are all the numbers 1 on, okay? A counting number, think of when you learn how to count, it does not include 0. A whole number, however, is 0 on up. So this is a whole number. A whole number includes 0. Okay, so if I have a 2-digit number, if I'm thinking of a 2-digit number like 10, 23, 35, so on, I notice there's one number that can never be in front. And do we know what that is? It is 0. Because if I were to put 0 and then another digit, let's say 5, 0, 5 equals 5. It's not a 2-digit number. So I can never put a 0 in this first spot. Now, my base 10 system means the numbers 0 through 9. That's what creates all the rest of our numbers. There are 10 of them when you include 0. So if I can put any number I want here except for 0. So how many are left? If I have 10, I take away the 0, I only have 9 left. And it says nothing about not repeating. It says nothing about any rules I have. So there's 10 options. I can use 0 again because 0 is 90, right? That's a number. So that's good. That checks out. So this would be 90 ways or 92 two-digit numbers that I can create from our base 10 system. All right, I know that's a lot, so read it or watch it again if you need to, but we are going to be moving on and doing some more examples. Find the number of 2-digit numbers that do not contain repeated digits. So now I start again. Remember, this cannot be 0. So there are 9 numbers left. And this cannot repeat. So if I use the number here, I cannot use it here. So I have to take 1 away. So I start with my 10 and I subtract 1. This is the repeat. So I'm taking away, for example, 99 or 77, 33. Okay, all the numbers where they repeat. So 9 times 9, there are 81 2-digit numbers that do not repeat. How many ways can we elect a president and secretary if no one can hold more than one office and the secretary must be a man? So I'm looking here. I've got Nate is a guy, David, and James. And I have 2 spots, my president, my secretary. I'm going to start with the secretary because I know it has to be a man. How many men do I have? 1, 2, 3. Once I've chosen my secretary, right, there's 1 less person. So there's 5 total people. But I'm taking away 1 person for the secretary because it says no one can hold more than 1 office. 5 minus 1 is 4. So there are 4 people that are left for that president position. So 4 times 3, there are 12 ways. How many non-repeating 3-digit numbers are there? So I have my 3 digits. And what do I know about a number? The first digit cannot be 0. So if it can't be 0 and I have a base 10, there's 9 numbers left. This number, I have 10 numbers, but I cannot repeat. 10 minus 1, there are 9 options. For this number, I now only have 9 numbers left. So now I do 9 minus 1, which is 8. So I get out my handy dandy calculator because I can't do that one in my head. 9 times 9 times 8, I get 648 ways. If I'm not allowed to repeat. So 111, 333, etc. Okay? In some states, auto license plates have contained 3 letters followed by 3 digits. How many such license plates are possible? So, 3 letters followed by 3 digits. Says nothing about not repeating or what I have to start with. There are 26 letters in the alphabet, so I do 26, 26, 26 times 10, 10, 10. So 26 times 26 times 26 is 17,576. This is 1,000. When I multiply those together, I get 17,576,000 ways. It's crazy to think that there's that many options for a license plate. Okay, last example. Vern has 4 antique golf clubs that he wants to give to his 3 sons, Mark, Chris, and Scott. So there's 3 people, and he has 4 clubs. So he has 4 clubs he can give to this first person, 3 to this second person, and 2 to the last person. 4 times 3 times 2 is 24. How many options are there if the driver must go to Mark and the 3 must go to either Chris or to Scott? So this first person, he only gets 1 choice. Okay, so this other 2 guys, one of them, so this is Mark, Chris, and Scott. And the 3 must go to either one of them. But that doesn't mean they can't have one of the other 2 clubs. So one of these guys is going to get the 3 The other guy has 2 clubs left that he will get. So 1 times 2, there are 2 ways. It's crazy how just by putting a couple of rules in there, it changes the whole game. So we go from 24 options. Now there's really only 2 ways that can work out. That's it for your notes. Go ahead and start working on your homework. If you have any questions, go ahead and let me know. Thanks. Have a great day.